Welcome and thank you for joining us for another episode of the Jane Irrigation Training Series. I'm your host, Richard Restuccia, Vice President of Water Management Solutions. And today we're going to be talking about something that's really important, I think, especially this year, and that's how to reduce nitrogen costs, how to manage nitrogen better, because what we've seen in the increase in pricing of nitrogen and other fertilizers in the past year has been astronomical. So if you're a grower trying to manage your costs to try to get a profitable product by the end of the year, managing especially your nitrogen early on is going to make or break you potentially. So today we're fortunate to have Aric Olson, President of Jane Irrigation, with us today to kind of take us through a couple ways that growers can manage nitrogen. Now, Aric's really unique in being able to talk about this, right? Aric's got a background in chemical engineering. He's got a BS in chemical engineering. He's got a master's in business. He's got a life history in agriculture. And then the other thing that Aric has really done is he's continued on his lifelong education and learning. He's a certified crop advisor. He is a certified irrigation designer, and just really has a unique background in both chemicals, irrigation, and design. One of the few people who could actually talk about this subject. So we're really fortunate to have Aric taking us through this today. Aric, good afternoon and welcome.
Thank you, Richard. Yeah, thanks for the nice introduction. And I would say a lot of folks in our organization have this unique skill set. We have many people that are certified in design, certified ag irrigation specialists, crop advisors. We are really a unique company that we can help growers with the irrigation and design and the agronomic aspects. It's really a unique company in our space.
Yeah, so Aric, I'm thinking about this nitrogen situation. I'm reading a lot about it lately, and I'm wondering, from your perspective, how big of an issue is this?
Yeah, it's pretty significant. When you look at the costs of, say, a commodity crop grower, the costs of nitrogen could be anywhere from 25 to 35% of their total cost of production. When you have, say, an almond farmer, a nut farmer, this could be 5 to 10% of their total cost of production today, given that we've seen nitrogen rates triple in the last year in recent months. So very significant. I'll have an example at the end of this presentation to just show the financial impact of this nitrogen price increases. And hopefully we'll be able to provide a few ways that you can save on the amount of nitrogen and still get the same impact and radically change the cost trajectory for this year.
That's really exciting too, because it's hard to imagine another business in which something so big, such an input to your costs, has changed so dramatically, right? 200-300%.
Yeah, it's very dramatic when you think that for a corn or soybean producer, if the nitrogen impact is 30% of your cost and you have a tripling of nitrogen, I mean, you've effectively doubled the cost of your production, mainly due to this fertilizer. So this slide here, kind of shows, this is from DTN, it shows the cost trend of the different nitrogens over time. And we've had pretty stable nitrogen prices from, say, 2015 all the way into 2021. And the last 6 months, just a radical price spike in all forms of nitrogen, really driven by supply demand. We've had some production issues in the Gulf Coast area, and those issues have really extended for quite some time. And now we're faced with natural gas pricing and issues with the Ukraine conflict that we have. We saw natural gas spiked in Europe, and to produce these fertilizers, it can be 60 to 65% of the cost to produce the fertilizers, the cost of natural gas. When you see this natural gas spiking in Europe, you can imagine that's going to directly impact fertilizer. We also have this global supply chain and logistics challenges. The value of fertilizer is a lower value per the weight of a shipping container. And so we ship then last fertilizer and we ship everything else, higher value goods. So the availability of shipping containers has exacerbated this problem. So really it's a supply demand story in the last 6 months, lack of containers available. And now we're dealing with natural gas, the input, one of the main inputs into building fertilizer. And so when you see this chart, you can think that a unit of nitrogen now is over $1 a pound. And last year it was, 40 cents a pound. So, nearly a tripling that the growers are dealing with. And
Aric, I just had a quick question on that. I'm sorry to interrupt, but I was thinking, as a grower, do I just have the choice of not putting nitrogen down this year? Could I just skip it? It's too expensive.
You could skip it, but it would be a pretty significant impact on yield. There's nitrogen, typically if it's a tree crop that are in the plant, you got some residual nitrogen maybe hanging around. If you're in a commodity crop, no, you might have some in the soil there, but you'd be taking a pretty big risk if you didn't apply, say, the 300 pounds of nitrogen per acre for various crops, and you would suffer yield at some point for sure. It's one of the primary drivers of yield. Growing crops, follows the laws of minimum. You need a minimum water, a minimum fertilizer, nitrogen, potassium, phosphorus. If whatever's the common least common denominator there is going to dictate yield, and nitrogen is really one of those main inputs. So yeah, you simply can't decide not to put nitrogen on this year. But nitrogen, as we've done a few webinars on fertilizer, Richard, nitrogen's super complex. It's like the Goldilocks of nutrients. It really needs the exact right environment, the right soil conditions, moisture, temperature, the right chemistry to be effectively utilized. If you have soil that's too hot, you can get volatilization. If your soils are too wet, you can have other issues called denitrification if your soil's too wet. And these all lead to losses then. And also, everyone should remember that nitrogen needs to be in the proper form for the plant to be used. There's only two forms that plants can uptake there, the nitrate and the ammonium. Those are the only two forms that the plants will use the nitrogen. And there's kind of a big continuum of a process. And when the environment's right, the nitrates or ammonium is available for the plants to uptake. The plant will take what it needs. If there's excess, it won't use it. And that can be thrown off or volatile, have volatilization or leaching, which is bad. Leaching is when the water carries the nitrogen through the root zone and into the groundwater. And those are really bad effects. Now, in agriculture, unfortunately, we have this thing, nitrogen use efficiency, and it's how much nitrogen we apply versus how much is beneficially used. So in agriculture, there's different nitrogen use efficiency statistics. In commodity crops, we might have a 50 to 60% nitrogen use efficiency, meaning, if we applied 100 units, only 50 or 60 would be beneficially used by the crop. Maybe best case, we could get to 80, apply 100 units and only get the benefit of 80. So where does those other 20 units go or 40 units go? Well, those go to the environment. They're either volatilized up into nitrous oxide, or they get leached into the groundwater down past the root zone, and they're not utilized. So when you think about that, there's a lot of waste that happens with fertilizer. And so part of this presentation is, if we could simply eliminate that waste, if we could eliminate 20% of the waste, well, we've just taken a bite out of this big cost increase. So that's the interest in us showing this presentation, is to try to help growers minimize the losses. The first main way to do this is to get the nitrogen timing as best you can with the crop. And most crops follow this general curve where, say, 80% of the nitrogen's used in the earlier stages of the crop growth. But this happens to be a picture of an almond crop and the timing. And you can see, nearly 80% of the nitrogen, when you look at all the percentages there that add up, are really fully utilized and taken up by the tree before mid-June. And this is the percent of soil nitrogen uptake. So if you look from January, February, and March, it looks like there's no nitrogen at all uptaking. Well, the tree is actually using the nitrogen already stored in that plant, and that's helping it for early season nitrogen use. But you can see in March and early April, you got to get 30% of that nitrogen on in the right form, in the right environment. And if you can spoon feed it, which is the next idea to save nitrogen, these are the two ways to really save. So if you simply put a slug of nitrogen on in February, a good portion of that may volatile, off or go with the groundwater and leach past the root zone. And so you really want to think about the timing and how many different nitrogen cycles you can put on. So these are the two big reasons here, or big ways to save. So reminder of a calculation, and this is, you can get help at your extension agency for the different crop types, but I have some experience in corn and soybeans, and then we're in the almond capital of the world here in the Central Valley. So I thought I'd use an almond example. And almonds, to figure out how much nitrogen you need, it's a pretty simple calculation that UC Davis has given us. For every 1,000 pounds of almond meat kernels, you need to apply 68 pounds of nitrogen per acre to make that yield. So if you want to get, you're going to get a 3,000 pound yield if your soils and water, all conditions will all support 3,000 pounds an acre. You take 68 times 3, and you need 204 pounds of nitrogen per acre. Now, how you apply that, you have to take and make some estimates on your distribution uniformity if you're applying it through irrigation, or you have to make an estimate of what your nitrogen use efficiency is or has been. And so you may divide this by 0.85. If your nitrogen use efficiency is 0.6, you have to divide that by 0.6. And you could quickly see that the value or the amount of nitrogen can quickly go up based on the uniformity of your irrigation system or the timing of how you apply this. I put in 0.85, which is very, very high. You probably would, might be lucky to get nitrogen use efficiency at 0.7. So, but for this calculation, let's use that. And we get 240 pounds of nitrogen per acre. And I'm a grower in the Central Valley, and I'm going to use liquid urea ammonium nitrate, UAN 32. And I need 240 pounds for the season to get that yield. I'm going to divide that by 0.32. That's the units of nitrogen there. That gives me 750 pounds of UAN 32 per acre. Another example would be CAN 17. I'm going to need quite a bit more of that. And that's the amount of nitrogen I'm going to need per season to get 3,000 pounds an acre. Now, as I said earlier, would we apply that all in February, or do we apply 30% before this May time period, right? So now you got to think about carving up the timing of that to help you make sure you get it when the tree actually needs it. So let's look at that timing and get that calculation for. So this is the main point number 2 is, now that we know the relative timing of when to apply it, what's the best way to do this? One shot on May 15th or March 15th, or, could I put a little bit on in each irrigation, or spoon feed it? And then spoon feeding is definitely the way to go here. So I know for the season, I need 750 pounds of UAN 32 per acre. I'm going to put on this early season application, this March 10th to April 10th application, and that's going to be 30%. That's what I'm going to put on there. And so 30% of the 750 is 225, and I'm going to put that between March 10th and April 10th. I'm going to have about maybe 12 irrigations. Maybe that's a little aggressive. This year that might be applicable. Maybe, yeah, that might be a little many irrigations. It might be 6, it might be 10, but let's, for the sake of the calculation, use 12. So dividing 225 by 12, you get 19 pounds per irrigation. So 19 pounds of the liquid UAN 32. That's what I'm going to need to put on each irrigation. A gallon of that weighs 11 pounds. And so I'm going to need 1.7 gallons of UAN 32 per acre per irrigation. And if I have 40 acres per irrigation set, let's say I have an 80-acre field and I got a 2-set system, I'm going to need 68 gallons of UAN 32 per irrigation set. And this would be really spoon feeding it 12 times each. I'll be doing that same amount, that's spoon feeding it. And that'll help you really improve the nitrogen use efficiency pretty radically and, help minimize the volatilization there. Now,
we've got a couple questions here. And the first one is on the spoon feeding. How does that help? Does it keep the nitrogen in the root zone longer, or what's the benefit there really?
Correct. Yeah, so if you think a normal irrigation event might be maybe 8 hours, and if you, and I'll show this slide in a little bit, if an 8-hour irrigation pushes water down to the root zone to say, let's say 28 inches is where that 8 hours of irrigation goes to. Now, nitrate will flow with the water. So you've just taken all that nitrogen and you pushed it down to 32 inches or 26. Most of the nitrogen uptake is going to happen in the top 18 inches. So you've just pushed a significant chunk of your nitrogen right past where the tree's mainly picking up the nitrogen. You really want to keep it in the top 18 inches. So getting the amount there set is very, very critical. It's not like water. Water can have uptake down to maybe 36 inches in the root zone. So it's a little different with nitrogen.
So now it's even made it more complicated, right? I can't really see my water below the soil line anyway. And now to think I have to watch to make sure that I keep my nitrogen in the top half. Do we have some tools that can help us do that?
We have some really good tools, soil moisture sensing with EC devices on them. I have those in a couple slides that will actually show where that nitrogen is going. And you can use that as a tool to make sure that doesn't go outside of your top 18 inches. So the general timing of the crop curve is important. This spoon feeding is number 2. And this here, I just want to talk now not only about the per irrigation spoon feeding, but within an irrigation event, when should I fertigate? If I'm going to irrigate 8 hours, should I just hook up my maize injector and run fertilizer for the full 8 hours? Should I fertilize at the beginning and then flush my system? Should I fertilize at the end and then flush the system? This is a huge opportunity for nitrogen use efficiency improvement. And, I recommend, if you can, and through automation you can, is to spoon feed this and do it in a manner that, can keep that fertilizer in those top 18 inches. So how would we do it in this example? If you had an 8-hour set, you might try irrigating for 4 hours, fertigating for 3 hours, and then the last 1 hour to clean the fertilizer out of your line. Now that last 1 hour is not going to push that fertilizer past that 18 inches, right? That's going to keep it there. And as I said, we have those soil EC sensors that can help you monitor that. So if this is the schedule you're going to take, you'd have 68 gallons divided by 3 hours. I'd need to inject this at 23 gallons per hour injection rate. So this would be a calculation that really gets you to spoon feeding it exactly when the crop can need it with the least amount of waste there. So big opportunity. So looking at the technology that can help you get this timing, we turn to soil moisture sensors. And the chart on the left is a traditional soil moisture sensor. You may have seen this from other webinars where we look at an infiltration chart that allows us to interpret all the lines on that other chart. We can see on that bottom chart how deep the water in the soil is penetrating. The vertical blue lines in the chart below represent irrigation events. The horizontal green line, represents the active root zone. This is a fairly large active root zone. It looks like we got 18 inches to maybe 48 inches is an active root zone. You can see those blue rectangles there. That's where those irrigation events, where the water went to. That first or second irrigation event there went down to 36 inches. We think that's pretty good for irrigation. Now, fertigation, again, we want to keep the soil moisture in the top 18 inches. So how do we do that? Well, we have to turn on EC sensors that look at salinity in this soil moisture chart. So this chart or slide may be a little busy, but just take a step back a moment, and really what we're looking at here is the EC or salinity content, which when you put fertilizers, those fertilizers act like salts, register like salts, and we're able to see fertilizer moving through the profile with the use of these salinity sensors. The chart there on the left is a high moisture content. We have too much water in the soil, a waterlogged soil condition. And when we go to fertigate, you can see the EC sensors at 16 inches are picking up movement or change in the salinity. That means that fertilizer probably got pushed past the 16-inch level, and this would be, somewhat wasteful, as we said. The graphs on the right shows where the soil moisture content is really in a happy range. It's not waterlogged and it's not bone dry. It's right in a very good soil moisture zone. And you can see the arrow on that red arrow on the right there, looking at the salinity sensor at the 4-inch level, saw a response on a fertigation event. But if you look below, that salinity sensor at 8 inches and 12 inches and 16 registered no response, meaning that nitrogen most likely stayed in the top, 4, maybe 8 inches. You can see a little bit of a blip there. So when you're spoon feeding nitrogen, as I recommended or outlined, you can actually use these tools to confirm that you're doing a good job with that fertigation schedule.
A couple of questions here, Aric. If we could go back a slide, actually 2 slides now. And this one, I love this slide, right? Because especially when I look at the improved graphic, it's really easy for me to see, the water traveling down, and I get that. Do you think that if you can't see that, you're more likely to, well, I better give it some extra fertilizer because I really don't know? Do you think that's what a lot of people do?
Yeah, the fertilizer, we're an irrigation company and we talk to, work with a lot of people. We have a water management business. So we see a fertilizer applied in just a huge variety of manners, from spoon feeding with the timing and really paying attention to, more of a broadcast method. So we see the full gamut here. Using these tools, this is really a way to help make sure that you're not wasting fertilizer and you're not hurting the environment as well. You're growing in a sustainable manner. So yeah, I think with automation that's coming in irrigation, those fertigation schedules will become much easier to implement something like that. That might look complex, what I was doing, and we don't have the automation, but we do, the industry does, and we have great automation tools that can help you do a really good job with those fertigation schedules, as I said.
And then on this slide right now, the one that's up, next slide, please. Really what I'm seeing here is that if I'm managing my water correctly and fertigating correctly, I'm really managing my nitrogen then.
Yeah, correct. The nitrates move with water. So if you're over irrigating or not getting the timing of the nitrogen right with your irrigation, you're potentially wasting a lot of your nitrogen that you're applying. And this is how we get these low nitrogen use efficiencies, in the 50 or 60%. It just, you put the water on and it just goes. And, there's certain soils that will hold this better. Sandier soils won't. If you got sandier soils, you really need to pay attention to spoon feeding. Yeah, but you're absolutely right, Richard. The case on the right there, that irrigation event is right in a happy zone. And that you can see is a very job well done, not only on the irrigation, but the fertigation as well.
So now I can see why it makes sense that I'm going to save water and also have higher yields operating this way.
Correct. So with the increase of fertilizer tripling, and you can just see, and this may not change. I don't know if the supply chain crisis is going to get sorted out quickly. We got energy and natural gas due to the Ukraine conflict happening. So let's assume fertilizer is going to stay high. The federal government's really even looking at the cost of nitrogen just to understand why this is happening. So very serious situation for farmers. But I ran a cost scenario here just to kind of understand what's at stake here, and the dollar per unit of nitrogen pound. And if you have, our example, I think we needed 240 pounds of nitrogen, but if you need 300 pounds an acre, again, depending on your nitrogen use efficiency, if you're not doing the spoon feeding and getting the timing perfect, your nitrogen use efficiency might be 50 or 60%. If you're doing, the highest level that I've described here, maybe you could get to 70 or 80. But if you want a 3,000 pound yield and your soils and the water and the environment supports that, you're going to need $300 per acre for this. A year ago it was $100. And if you had 80 acres, that's $24,000 nitrogen bill for that farm. Prior years, 8,000. So just a huge difference. If the prices, of almonds, let's say $1.75 for those 3,000 pounds, that's the revenue you're generating, 420,000 pounds for that 80 acre farm. And you can see 24,000 divided by 420, that's 5.7% of the revenue is just going to nitrogen this year versus last year is 1.9%. That's nearly 400 basis points of margin erosion for the grower. And so if you don't do anything, that's the type of financial destruction we'd have. So very devastating. So if we can simply do some of these tools, the timing and the getting that spoon feeding, and then within the irrigation scheduling as well, those three things, we can put a dent in this margin and dollar loss for the grower.
So Aric, would I be right in thinking that, well, the grower is going to come out okay, they'll just get a higher price for his commodity or his almonds this year?
Yeah, unfortunately, and this is always the case, and I wish I could fix this, the farmer is always the one that seems to suffer. The fertilizer companies seem to just pass any price increases straight through to the farmer, and the contracts on the crops get decided by big ag players. The price is set like a commodity, and they're really pinched. And the only way is to figure out how to get by, how to be more cost effective, how to help the growers reduce their costs. And so in this case, I don't believe that the growers are going to be able to increase their almond price by 400 basis points to compensate for the fertilizer costs. The market's just set for those nuts. So it's really kind of a poor situation. This happens in corn and soybeans and other commodity crops as well. The farmer's in the middle, and you have these higher input costs, and the markets, you have big buyers, and the farmer's in the middle trying to just make a living. And so very difficult. So, that's why we do this work that we do, Richard. We try to help growers, provide a lot of education. We have a water management service, that we deploy to really help growers solve some of these and work through some of these significant financial issues with the that nitrogen and other fertilizer costs going up almost 3x. We know nitrogen's so challenging to manage. I think the easiest thing is to get the timing when the crop needs it and get that timing down. That's idea number one. Idea number two is spoon feed it. And then really fertigate to keep that nitrogen in those top 18 inches. That example we gave, irrigate for 4 hours, fertigate for 3, irrigate for 1. That can help keep the nitrogen in those top 18 inches. And then utilize those EC sensors and tools that are available to help you make sure you're not wasting any of that nitrogen. And then, this is all pretty heavy, and farmers have a difficult job. They have to be agronomists and business people and irrigation people. And but we are here for you. We have a water management services that we deployed a year ago to provide growers weekly irrigation schedules. We have a staff of agronomists that understand fertilization and can help you work through this, to use these tools to get through this fertilizer and energy situation. So we're there for you. We're in year 2 of that. We still have capacity. I'm looking for a few growers to take on myself. As you said earlier, I have a experience in design and certified crop advisor, and I'm looking to help some growers this year with a couple of people that I'm working with as well. So we'd love to help any growers out there work through this nitrogen and then the very difficult water season that we're having in California.
Yeah, whenever business gets tough, right, Aric? In my business, I'm always looking for ways to save, right? When I feel a pinch coming on, and when I see something like nitrogen use efficiency so low, man, and it being so expensive this year, seems like this year would be the best year, or hopefully it's the best year, right? And hopefully this doesn't get worse next year, but this would be the year to give it a try if I was going to, right?
Yeah, absolutely. You can see the financial impact. It's not only significant for nut crop growers, but the commodity crops, face the exact same thing, and maybe worse, because nitrogen is a much higher % of their operating cost than compared to a nut crop. So that, very significant for all growers this year.
Yeah, and Aric, I see you putting your email address on here. What a generous offer that is, right? To put it up there for help and questions. And boy, I don't think anybody's going to find any other presidents of any major irrigation manufacturers willing to help like you are. And I think it's a really special offer and really nice of you. And I hope a lot of people take you up on it.
Okay, thank you, Richard. Yeah, appreciate it.
So thank you, Aric, for helping us today. Boy, I always learn so much when I hear you present and talk. It makes me excited to go out and be better, right? Be a better water manager or a better nitrogen manager in this case, maybe one and the same. So thank you. And I want to say thank you to all the viewers today. We really appreciate your time and your commitment to improving conservation with us. Remember, you can see all our trainings on the janesusa.com website /trainings. And anywhere you listen to your favorite podcast. Like I always say, I always get excited when I think people are doing their day-to-day jobs, listening to our podcasts and improving their sustainability and water conservation practices as a result. That's what gets me up every day. So anyway, Aric, thanks again. Really appreciate it. Thanks to everybody. Have a great weekend. And we will see you back here next week. Thank you.